So we will continue the lesson. So I have to drill these holes in the model. So I will use a new technique. I will teach you how to use the 3D mirror tool for this one. So I have to drill this hole. It's 25 millimeters in diameter, 250 away. So we will select this as the sketch plane, and now I have to locate the center. If I click on these areas, sometimes the center will be shown for me. So if I click on the hover on this arc center is the same center for the circle. So you don't need to draw center lines and locate this again. This will save your time. So this is 25. Now if you want, you can have extrude cut for this shape. Or else you can apply a mirror and get this side a 2D sketch. Say I will apply that one. Say I will apply a 2D mirror. This is the entities to mirror about this one. So that's why we ask you to have all the things symmetrical. Then it's easy. Mirror about this plane. It's not selected. So the plane is not selected. So you have to sketch it. So I forgot that. I have to sketch a center line. Then I will apply mirror. Mirror about this. So this is another way. Then we can apply cut and then get say up to next. This way we can complete our design. Or else if I roll back this is another method. Draw the 2D circle, hover over here and get the center, which is 25 again. Now without having the mirror, I will cut this. Now I completed this side. Now what we can do is there are 3D mirror tools available. So this is a 3D mirror. So we will discuss the theory after a little while. So we can apply the 3D mirror tool to get this shape. So rather than getting a 2D mirror sketch and cut both sides, here I'm going to apply a 3D mirror to this feature. So we can apply the 3D mirror to the features, faces, or bodies. So I will apply the 3D mirror about the plane, say about the right plane. Feature is this cut. So you can select from here or here. And if I get the preview here, you can see it's formed. So this is how we apply the 3D mirror. So we are applying it for the feature, not for the sketch. So we can get the result like this. So now this 3D mirror appears in the design tree nicely. So you have the parent, you have the child also. So if you want to suppress the child, easily I can suppress the child and I can have only the parent. I can unsuppress the child. So if you suppress the parent, both child and the parent will get suppressed. So that's how it works. So you have that parent-child relationship. So unsuppress the parent and unsuppress the child. So this is another way, or else you can do that. Do a 2D mirror and cut it both sides. But personally, I like this way because now I have more control over here. I can remove this one, or I can show only this one. So I have more control over this 3D mirror rather than the 2D mirror. So you can apply this 3D mirror tool and see it's similar to the 2D mirror. You can apply for the features as well as faces or else bodies. So I applied for the feature, cut feature here. So that's the end of our chapter 6. You can try these tutorials and get used to the software. So any questions about this tutorial? So this thing I didn't do this exercise. These things also you can practice and get an idea how to do the how to use SolidWorks in an effective manner. So any problems up to chapter 6?
Can you repeat 3D mirror part?
Excuse me.
Can you repeat that 3D mirror part?
Repeat what?
3D mirror part.
Huh?
3D mirror part.
3D mirror. So I completed one side. So I completed the 2D sketch and I cut it. Then we just went here at mirror tool. This is we have to select the symmetrical plane. So symmetrical plane in my design is right plane, and features to mirror is this one. So I have the feature cut feature. Then we just press OK. This is more flexible and more useful than the 2D mirror. So that's the end of chapter 6. We will start chapter 7. So under chapter 7, I'm going to look at the simple hole operation, hole wizard operation, advanced fillets, uh, simple and advanced fillets, how to use the shell operation, how to use the wrap operation, so those kind of things we are going to do. So chapter 7, we have these kind of tutorials. Now the models are getting complex day by day, so we will be able to complete these kind of models easily after we do the chapter 7. So you can see in this chapter 7, if you look at this model, we have applied 3D fillets. So this is a plain sketch, plain 3D model. So these are the 3D fillets we have applied. So we have done 2D fillets, but 2D fillets will not help us to make the 3D models this kind of a shape. So we have to use the 3D fillets and 3D chamfers to get these kind of shapes. So we will look at how to do these tutorials. Before that, we will look at some theory parts. So I will start with the simple hole tool. So if you work in SolidWorks, sometimes you have to drill holes. So earlier I drew a circle and cut it. So if you want, you can do that way. Or else there are direct tools available in SolidWorks called simple tools. So I will take a model and show you how it works. I'm moving to chapter 7. So I will take this first file 7.2. So if I want to cut a hole, drill a hole, you just draw a circle and cut it. Or else there are direct tools available in SolidWorks. Uh, Under Hole Wizard, I have Hole Wizard and Thread. But where can I find Simple tool? So there's a tool called Simple. It says it's customized to add, so it's not available in normal interface. You have to customize the interface. Otherwise, you have to go through this path. Insert features, Hole Simple. So I have to go through that path. Insert features, and I can find a tool called Simple here. So this is simple hole tool. So insert feature simple. So when I select that, it says select a planar face. So I selected the planar face. Now directly it will draw the circle for me and have a blind value 10 millimeters. So if you want to change these values, you can always double click on these things and change it. So I can change the diameter from here and press OK. And it says line value. So OK. This way we can quickly drill a hole. So rather than drawing a 2D sketch, directly we can do it. So I will do it again. Insert features simple. So this is the tool available simple. You just need to select the face and it will locate it here. So if I want to locate in a certain position exactly, we have to put the dimensions to the center. So we can expand this and use smart dimensions and locate it correctly. So if I want to locate it 25 exactly, later we can locate it correctly. Say 25. Now it's a fully defined sketch. Now I can exit. So you can place the circle, later come and edit the center point. So that may be easy. So I just went to insert features, simple. Just place the hole wherever you like. Adjust the diameter, adjust the depth. So you can use all these options and all these options also. Just place it, then expand and go to 2D sketch and put the dimensions. So this may be easy. So this is about simple tool. So in this previous tutorial also we did we can use the simple tool and do it rather than drawing a circle and cut it. Directly use the simple tool and simple hole tool and do it. And now if I want to apply these standard nuts and bolts, we have to use the standard bolts. So you may have heard about counterbow, countersink, those kind of nuts and bolts, tap holes. So there are a lot of standard shapes. So if you are trying to find nuts and bolts, or if you want to do it in a standard manner, you have to use this hole wizard tool. So we will look at how the hole wizard tool works. If you want, you can go through this path and get the hole wizard. Or else I can just browse it from here. Hole wizard. So hole wizard is similar to the simple hole tool. You need to select the hole type. So in the exam or in assignment, we will give you the hole type you want. But if you do your own designs, you have to select the correct hole type. And if I select the counterbow, that shape automatically will come to my model. and I can use these American standards or British standards, BSI, ANSI or ISO. There are Japanese standards, so there are a lot of standards available depending on the workplace. You select the standard. Then this is the size of the hole, M5 size, and this is the tolerance, normal fit or a close fit or loose fit. Likewise, this is the through hole cut. So if I after you select these parameters, we have to go to position and place it in the desired place. So I placed it say here and press OK. So these standard settings will be applied, and it says counter bow for M5 headset bolt. So this hole will be suited for a counter bow M5 size bolt. So you can buy the bolt from the market and directly put it. So we don't have threads here at the moment, but it's not necessary to show the threads in a 3D model because anyway the manufacturer will cut it for you when they manufacture the part. So sketch, if I you have two sketches now. So if you edit this sketch, it will show the center point of the hole. So I can adjust the center point by putting a dimension, and the second sketch will show you the shape of the counter book. So this is how it has been drawn. So if you know these parameters, you can draw it. Yeah, the idea is you don't need to know these things. You have to know only the minimum information. Software will draw this shape for you. That's the whole idea. Then you can buy the ball from the market and put it in this hole nicely. So I will do it again. Hole wizard. Select a ball type. Say countersink this time. And these parameters you will learn in your design classes how to select these parameters. So this is the M5 size and through hole, and go to position here and place it wherever you like and press OK. Later we can adjust the position. So this is the counter sync. This is the counter bow shape, and if you expand this is the sketch. So this counter sync sketch is different from counter bow sketch. So we have a tapered angle here, 5.5 to 25, same here also. 5.5 is there, but you have a flat shape. 25 is the true cut. So I hope you understood how to work on this. When we do the tutorials, we will use these tools and show you how to apply these things in a professional manner. So when I look at these tutorials here, here we are using these standard holes. So when I do the tutorials, these are standard holes. We will use them as it moves on. So I hope you understood how to work on the advanced and simple. Sorry, hole wizard and the simple hole. So all these parameters you need to either look at from design books and change them, and according to your calculations you have to do it. So this is the counter bow shape, counter sink shape, drill holes, tap holes. Likewise, there are different shapes. Next, any questions about this? So I will move on to the next area. So if you don't have questions, so we will look at the fillet tools. So here the basic idea is to learn about 3D fillets. So we will take a small example and start this. So I can take the same example here. Now I want to apply fillets in a 3D manner. That is, I want to apply the fillets to the 3D model. So you can apply fillets like this. So we will apply it and see. So we don't use the 2D tools anymore. So we have the 3D fillets and chamfers. We will apply the 3D fillet now. So there are four options available: constant size fillets, variable size, face fillets, and full round fillets. So we will use the constant size. Constant size is the radius is same throughout the edge. So when I select this edge, automatically it will select the entire edge, and radius is 10 millimeters at the moment. We can change it, and this is a symmetric fillet. That is, both sides of the fillets, this side and this side, are symmetric. So when I press OK, I'm getting this kind of a appearance. So this is a 3D fillet which cannot be achieved from 2D sketches. So 2D fillets cannot be used for these kind of shapes. So I will again edit it, and if I have asymmetric fillet, that is, you can have different values. So 10 from here, 10 from here, uh, we can change it to say 20. Now this distance is changed. So this is not a symmetric shape, it's a asymmetric fillet. So now I will delete this and apply again. Now when you click on this, you may get these kind of options. Early SolidWorks versions didn't have these options. So if you select this one, connected to start phase 3 edges, software tries to select the other edges for you. So he is trying to select the other edges for you. Otherwise, you have to do it manually. So these operations, internal to feature. So he's trying to select all these edges for you. So this may helps you to save your time. So just click on this, and you should get these different options depending on the version you are using. So if you are using a new version like 2016, like me, you have to get these things. All versions may not have these options. So all these just selected. So otherwise, you have to manually do it one by one. So if I want only these four, just select only these four and press OK. Or else, if you want to reduce the time further, we can just select this face. So once you select this face, all the edges connected to that face will be filleted. Say I will say 5 millimeters. You can see these are also getting filleted. Okay. So I can actually use this edge or the face, or I can select the entire body like this. So it takes some time to generate. So I selected the entire body. So I think these millimeters are too little, too much. So I apply 1 millimeter. So everywhere you experience the fillets. Okay. So you have a lot of options. One way is you can select the edges. Other one is you can select the faces here. Or else you can select entire thing. Or else you can select what? You can select this feature also. So when you select this feature, only that feature will get filleted. You can see this area filleted, this area is filleted. So there are a lot of ways of applying the fillets. One way is you just select the edge and you have these options popping up. Or else you select this face. Or else you select the entire body. This, or else you can come here and select the features also. So you can see how it works. So all these having the same millimeter diameter radius. So do you can see any questions? Let me know. Now, so this is a constant fill size filler. Now suppose you want to say this is 5 millimeters. If I want to have 10 millimeters here, you can do it several times. Or else you can enable this multiple circular filler tool. So once you enable that one, you can have a different value here. Say double click on this and I can have a different value. So after you enable this multiple radius tool, you can have a different value here 10 and 5 millimeters here. So this will helps me to have different round corners. So I have three values now. Still it's a constant size. Constant means it throughout the edge it's constant, but different edges have different fillet radiuses. So I hope you understood that also. Normally we don't practice these kind of designs. These are irregular shapes. Manufacturing wise also difficult, so we will not do that. If you look at your mobile phone, everywhere the same fillet radius is there. So we don't try to have different values in different places, which is going to be difficult in manufacturing. Better you put full preview on, then you can see it. Otherwise, you may not see the correct output. Tangent propagation is if those edges are tangent to each other, automatically the entire chain will be selected. So here these are 90 degrees. So I have to do one by one selection. The tangent propagation will not work in this manner. And the profiles are circular, so you can have different shapes. I will discuss these things later. Any questions up to this? Okay, so we will look at this one. So if you look at this picture, I have selected three edges, and I have adjusted the fillet concentration here. So the lines are more lines here compared to here. So this is called setting the setback parameters. So I will show you how the setback parameter tool works. So we will have same radius. I will do it from the beginning. So if I want to fine tune this common vertex, we can use the setback parameter tool. So I will apply the fillet to this edge, and this edge. So you can see some smoothness is here. And if you look at the options available here, there's an option called setback parameters, and we can select the setback vertex. This is the setback vertex. So once you select the setback vertex, the idea is up to 5 millimeters from here and here and here, it will be fine tuned. Now when I press OK, you have a finer result. Earlier it was like not like that. So I will show you without the setback what is the output. This is without the setback. This is the result. So when I apply the setback up to 5 millimeters, you can change the distances separately and you will get this kind of output. So you can see the difference. Earlier it was like this. So setback parameter will helps you to have a smooth vertex. You can do it and see. So when you increase the distance, that smoothness will further go away from the common vertex. So this is another option available in fillets. When you apply the fillet to an edge, sometimes the existing features may be suppressed. So if you want, you can suppress this existing extrusion and the cut. Or else you can keep that extrusion and the cut and apply the fillet. So this is called keep feature tool. So you can apply the keep feature tool and keep those previous features when you apply the fillet. So we will see how it works. So I will open a file. Say I don't have the exact file with me. I will open a file somewhere down the line 7.79. This file. So this is applied for the chamfer also. So you can apply the fillet to this edge. Once you apply this fillet, you can see these features will get affected. If you just press OK, these features will be kept and the fillet is applied. So you automatically these extrusions normally starts ends here. So these things additionally software is handling it for you, so you don't need to worry. But if you say don't keep the features, there's a button here under fillet parameters, sorry, under fillet options, keep features. If you just untick this tool, don't keep the features, what will happen? This is the result. So basically, these extrusions is going to be uh, suppressed. So I didn't suppress manually, but software automatically suppress them. So you have to remember there are tools like that in software. Keep features. So you can quickly keep the features and let the others to get the fillet. So I hope you understood that option also. Any questions? Let me know. So we started with the simple edge, then we went to multiple edges, faces, features, bodies. Then we had different radiuses. Then we had I talk about tangent propagation even. Then setback parameters. Then key features. Then if I want to have different radiuses, this kind of a fillet, normally we don't do this. We can acquire this by varying the radius throughout the edge. So this is not a constant fillet. Uh, if I take this edge, we can apply that. So I have to move on to the second option called variable size fillets. So this edge, throughout this edge, I have different radiuses. So it says variable radius unassigned. So I have to give a value, say give 10 millimeters, and this side may be 5 millimeters. So you can see how it changes. Now, if I want to give middle values, you need to just click on this surface. After part of the line, I can have a value, say 14 millimeters. After half of the line, in the middle of the line, we can have a value, say 10 millimeters. So you can assign different values throughout the edge. So if you want more points, you need to increase the number of points. So we can increase the number of points from this tool. You can see number of points are increased. Now I can give another value here. So that transition can be smooth or else straight. So when you change it, you may not see the drastic differences. It tries to make it smooth and tries to have straight transitions. So if I just delete this, maybe obvious, smooth, straight. So we can have different radiuses throughout these percentages. If you want, you can double click on this and change that even, no problem. And the position will change. And that's okay. This is the outcome. So any problems, let me know. So you can increase the number of points and have a smooth or straight transition. So we will move on to the next uh, one. This is called phase filters. So you can see the outcome. What is the outcome I'm getting? If I want to get this model up like this, so normally we will go to the editing and we will try to change the shape and get the shape somehow. So, but rather than doing that, we can use the face fillet tool and select this face and this face and apply a fillet and get this shape. So I will show you how it works. So the fillet tool will save your time if you know the techniques correctly. That's why even though I don't have much time in the syllabus, I'm teaching these things. So without skipping these important things. So now if I want to have a round shape here, normally everyone will go here and edit the sketch and make it a round shape here. But no one will think that we can use the fillet tool here. So fillet will have that option. It's called face fillets. You need to just select this face and this face. So when you select these two faces, make sure you select it in the second set. So you don't select in a single set, you have to go to the next set and select this. So once you select this, if your radius is enough here, it will generate a fillet for you. So I will come, I'll do it again. Fillet, face fillet, select this one and here this one. So and you have to go here and increase the diameter a little bit. Now 10 millimeter is not enough for this fillet. So the 20 millimeter, the idea here is if I put a 20 millimeter cylinder here, it will fit to this location. But if I try to put it 19 millimeters, it's okay still. 80 millimeters, it's going to fall here. So if I put a 18 millimeter cylinder here, it will fall here. So you can't get a fillet. So the less minimum value is uh, 20 or 19. If I have 30, the fillet will be this way. So if I increase the amount, it will go out of the boundaries. So this can vary. So this is the out. So face fillet may be important in some cases. So remember that tool also. It's not a difficult one. You just select these two guys. You will try to connect these two faces using a fillet. So it depends on the gap between these two edges, two faces. In this design, 90 millimeter is the less minimum value. Now I will move on to the next one. Uh, if you look at these diagrams, you can see different faces have been selected. Now this is the model I have at the moment. If I want to get this kind of round corners in my model, uh, we can't use the normal edge fillet. So I will open this and show you what are the problems we are getting. This one 755. So I may have this kind of a model. So if I try to apply the usual first option constant size fillet, tangent propagation is on. That's why it took the entire chain. If I remove this, you can see only up to here it's working. So this is the meaning of tangent propagation. Takes the entire chain, tangent lines. Now if I apply 10 millimeters, you can see this kind of a result is happening. I cannot get this kind of a shape. I can't extend this fillet up to this edge. So you cannot get that kind of a result. If I try to increase the radius, uh, you won't get it. Simply you can't get it. So you cannot see that result. So what we can do is we have to delete this and do it in a different manner. You have to use that last option called full round fillets. Sorry, face fillets again. So I will use the face fillets and face fillets and select this face as the first one. Second face is this. Tangent propagation still working. But you cannot see this same output. So I have to extend this fillet up to the last edge, this bottom edge. So how can I do that? There's a tool available here called whole line. So we cannot get it from the symmetric tools. We cannot get it from the asymmetric tools. I didn't discuss about the code width. I will discuss the whole line tool. So I'm going to use this whole line tool and stretch the fillet up to this line. That's what I'm doing. So I selected the phase 1 here, phase 2 as this one, tangent propagation on, and I use the whole line option and selected this as the whole line. Then what happens is my fillet will get stretched up to this line. So now it's not following a circular profile actually. So this is the outcome. So you can see the bottom is perfectly flat. Top side is getting filleted. So you can try this option and see. This is called whole line option. Okay. So there is another application here how we are using the whole line and the curvature continuous. There's another option called curvature continuous. Now if I show you that option, now this is the whole line. This 757. You can see two fillets have been applied. One fillet is going up to this point and one is ending here. So if you just look at the options I have used here, this fillet tool uses the tool called whole line. So the whole line is this edge and this edge. So but it cannot continue up to here. Even though I hold it, say if I just have symmetric fillet, this is the result. So symmetric fillet, I just selected this face and this face. Symmetric fillet will only have a fillet up to here. But if you apply the whole line, this is one of the lines, it will extend up to here, and this is another line. It won't extend up to here because it's not enough. This fillet radius is not enough. So we can have a tool called curvature continuous now. So what happens now when I click here, it won't have a circular profile. It will have some elliptical shape, kind of a elliptical profile and continue up to this whole line. So we have two whole lines, this one as well as this one. But if I have a circular profile, it tries to have the circular shape always. But I want this edge to come up to here. Then we will see. We will select the curvature continuous option. So now it won't have a circular shape, kind of elliptical fillet we are getting. So we are getting this out. Okay. So I'll do it from the beginning and show you how it works. So these are really handy tools, otherwise you have to go and do editing in the sketch level. So I will just apply a normal face fillet, this face and this face. It's a circular shape. I won't need that, I need a whole line here. Still it's circular and a whole line here, but it won't go up to here. Then we will apply curvature continuous method. So it will continue up to this point. So you can do it and see any questions, let me know. So we will continue the lesson. Now if you look at these two diagrams, I have applied the fillet here, and this side the material is more than this side. So you can have a constant with option clear or constant with checkbox selected. So this is with the constant fillet radius. This is without the constant fillet. So I will show you how it works in the new module. So I will take 758. So we can apply fillets, and if you want you can use the normal constant size fillet P1. So when I click on this, automatically the material here is more than here. So you can save less material here. So to prevent failures, software automatically puts more material this side. So this is done from normal edge tool, so normal constant size. If you want, you can apply the face fillet tool also. Face fillets are, first face will be this, second face will be this. Automatically the material will be more here, but you are getting an option here called you are getting the option called constant sizes. So I will go down a little bit and try to find it. Say this one, chord width. So when you select this chord width option, everywhere the same fillet radius will apply. So when you apply 20 millimeters, everywhere it's 20. But if you apply symmetric, automatically this material will be there, more material will be there, less material is here. So this is the meaning of chord width. It will have the same fillet radius throughout the part, throughout the circular edge. So this is the outcome. And if you have apply a symmetrical one, you can see the more material is automatically applied. So remember that option also in face fillers. So you can find that option only in face filler, not in the constant edge method. Then we have the last one. This is called full round fillets. So if you have a 3D model like this, you select this face and the other face there, you can obtain the circular shape quickly. So I don't need to cut this thing and get the shape later. We can apply the fillet quickly and get that shape. So I will show you how it works. If I take 761, apply the fillets. Last option, full round fillets. So I have to select the faces correctly, corner face, middle face, and the other side face. So automatically, if you have done the correct designs, this is applied for rectangles also. You don't need to give a radius. Automatically the fillet has been applied. But make sure you select the middle face here, corner faces as the first option and the third option. So you don't interchange this. So face 3 should be in the middle and the two corner faces. So quickly I can get this shape. So these tools will be used in our tutorials. When I do the tutorial, I will show you how we can use this filler tool. Any questions about this
So can you repeat the last one? The
face full round fillets?
yes, please.
It's easy. So you need to have this kind of a model. In our tutorial also, last tutorial number 3, this one, uh, we will use that option. So when you get this kind of a tutorial question, don't get confused. You need to remove all these 3D things, 3D fillets from your mind and visualize it without the 3D fillets. So when you visualize this without the 3D fillets, it's simple, something like this. And if you remove those, if you try to think this as a solid object without holes, then it will be much simpler. So we need to remove all these 3D fillets and the holes, and try to sketch only the solid object. So when you try to sketch the solid object, it's a simple object like this. So we can apply these contour selections and get the shape this way. So once we get this shape, now we have to apply the fillets. So we can apply full round fillets here. So what I discussed at the moment, last two, I can apply the full round fillet and get it round shape. Same thing here, round shape. Same thing here, round shape. So we can apply a lot of full round fillets and get these shapes. So you think like building blocks, rectangle, cubes, cuboids. Then we can later make them round. So then we have applied this bracket. We have drawn this bracket shape separately, and we have drawn these two boxes separately and applied the shell feature. We didn't discuss this at the moment. Shell feature and remove the material inside, and then we can have cuts. So cuts can be done at the end. So when you have a 3D solid object, you can easily cut them. So no problem. And apply the fillets here. So later we can apply the finishing and fillets there. So we will look at how to do this tutorial in a while. We have to discuss the shell tool before we do those. Now I will not be doing every tutorial we have in this set of tutorials. We don't have much time left. So we will look at the shell feature and do this last tutorial. Then at home you can complete that. So before coming to the chamfers, we will look at this again. Now fillet, last option, full round. Make sure you select this as the middle face. In the diagram also it mentioned, and the side faces are this one and this one. So you can quickly get the shape. This is not a difficult one. You don't need to give radius. Automatically the radius is taken as the semicircle. So this is a circle. So radius will be automatically taken. So that is about fillet. Now if you want to remove the material here, we need to apply shell operation. Now if somebody wants to have a hollow object, something like this, we cannot use the normal cuts and get this. It's very difficult. Some simple objects we can use the normal cut and do, but suppose if you want to remove the material here inside, I have a circular shape here, I cannot cut it. So we have to use the shell operation. Shell will make sure it will generate a thin wall feature. So you can click on the shell tool, give a thickness, say 2 millimeters, and click on the face you want to cut. So when you click on this and if you get a preview on, you can see this has been cut 2 millimeters away from the outer border. So if you want to cut it outside this way, also possible. Press OK. Now the material is going to move. So you think as a solid object, and at the end we can make it a shell hollow object. So this is how the shell tool works. So it's really important when you design these plastic material designs. Lot of these designs are inside is hollow, so you need to use this shell option. And if you talk about the multiple thickness, that is now everywhere we have 2 millimeters. If you want, you can have say some other millimeter here, say 4 millimeters in this. So what happens here now? This side will be 4 millimeters, other sides will be 2 millimeters. So you can see the thickness changes. So this side it's 4 millimeters, these sides 2 millimeters. So you can have different thicknesses actually in the shell. So I can select this face, and this face can have say 6 millimeters. So this will have 4, this will have 6. So okay, now different thicknesses. So you can apply shell tool also and see any questions. Let me know about this. Okay with this shell tool. So we have a tutorial based on the shell tool. Uh, I may not do this with you, so you can try this. And they are using the standard also. So uh, now this tutorial, the inside is hollow. You can see its inside is hollow. So they have started the model as a cuboid and applied the fillets. And after applied the fillets, we have to remove this area and shell this. So if I want to remove this and this also, we can use the same shell operation without doing cuts. So I will show you with a simple example how it works. I will open the cuboid. Say first one, this one. Now, if I want, I can apply the fillets and do the shell, or shell and fillets. So that depends on the design you do. Say uh, if my fillets are very complex and if the fillets values are very small, better you uh, do the fillets first and do the shell. Otherwise, if you try to do the shell and do the fillets later, fillet operations may get collapsed. I hope you understand what I'm saying. If I shell the model first, and after I remove the material, the thickness is very low. So when I try to apply fillets later, sometimes the fillet operations may get fail. So better you do fillets first and do the shell. That depends on the application you are doing. So sometimes you have to do the fillets first, then shell, or shell first and do the fillets later. So in this example, we will apply a fillet and do the shell. This is a simple example. So we will apply a fillets. Say I will apply for all these faces, constant size, something like this. Now I will remove the material. So I will apply shell, and shell thickness is say 3 meters. Preview on. So now this will be my result. Now if you want to get this kind of a result, remove this area also. Shell operation can be used again. So rather than selecting this face only, I will come here and select this face also. This face also. Now what happens is you get something like this. This is really useful in SolidWorks. So I didn't cut this separately. So I applied the shell tool for that thing. Then you will get a, if you select this fillet also as the shell face. I select the top one, this one, and this one. Okay. This there is a violation. There is no offset into an adjacent face. So it's not giving that option. It's not supporting me. So here in this design, it's not supporting me. But if you select this one, you get something like this. So, so the shell operation is really useful. Otherwise, you may have to cut this separately. So you have to think in a different manner. So in this tutorial, what they have done is they have shelled this space, these spaces also. Then you can get this kind of output. Then you can model these extrusions.
So
So I'll just try this one at home and see.
excuse me.
Yes,
Can you repeat the removing part? One phase.
it was. I just selected this one, and you have to select these other adjacent faces. So if you select all these three faces, everywhere material will be removed. You get this kind of shape. So it's very easy. So shell operation is helpful in that manner also. So normally people will think our shell is only to remove the top material. This is the basic operation. But if you select these other surfaces, all will be removed. So select this depends on the measurement. So sometimes it may not allow. So I select all the four faces. This is the outcome. So we will start this tutorial and I know this is my third day. Normally I plan to I will not do assemblies with you. I don't have time to do these things. So I won't do this assembly. So you will not get tutorials from assemblies. I hope to give an assignment soon. I will give the assignment. So we are in third day. So I have completed up to 7 chapters. So these chapters are somewhat advanced topics. It takes some time. So I will try to complete these 4 chapters within 2 days. And we have to go to the simulations also. So this is a very tight schedule in your syllabus. So I will try to give maximum as much as possible. I won't be able to do assemblies and drawings with you. So it's not going to be feasible with this time available. So uh, uh, we will look at the tutorial now, chapter 7. Before we go to the tutorial, I will do this tutorial with you 7, uh, tutorial number 3. Before we go to the tutorial, we will look at how to apply 3D chamfers. So 3D chamfers are also available. Before that, we have the fillet expert also. So I will complete the fillet option and come to the chamfers. There's a tool called fillet expert. So we will do this and finish the fillet tool first. So I will get that model. 766. So some fillets have been already applied to this model. So I'm going to use this second option called fillet expert. So the fillet expert is similar to fillets, but it has some other options. You can add the fillet. So similar to the earlier cases, we can add the fillet. Or else we can change the fillet. We can come here and change the size. So we can remove that. So it says unable. So sometimes it may not give us permission to remove. Here also it's not. So it's not giving me options to remove. So I will just apply here. Apply. And if I want to remove it, just I try to remove it. It will allow me to remove. So it allowed me to remove these ones, the ones I applied myself. And there's another one, interesting one called copy in the fillets. So if you look at this model, this fillet shape and this fillet shapes are different. So normally in the designs we don't do that. We have to have the same shape throughout the design. So better we have this shape here. So automatically this shape came. So I need to copy this shape here. So this expert tool helps me to do that. So you can copy this shape to this target. So I select this as the parent, this as the child, and copy to that. So you can see how the copying matches the similar shape. Sometimes you will get that odd shapes, two different shapes. So we can have a unique, uniform shape throughout the edge. So fillet expert will helps me to do that. So after I apply the fillet expert, you can see there's nothing coming as fillet expert. So it's not coming to the design tree. So what I'm doing under fillet expert won't come. This copying tool is not coming here as a feature. So I hope you understood what I did. Any questions? Let me know. So that is the only new tool available here. This copying tool. These are already available in the manual methods also. So these two methods are available in the manual method even, but expert tool is having this copy pasting method. So if I try to copy this one to this side, sometimes it may work, sometimes it may not. So it will. So I hope you understood the concept. So I will move on to the chamfers now. So we will look at how to apply 3D chamfers. We take the 766 file. So we have these methods available. These two methods are available in 2D sketches also. And we have a new one, vertex. We will look at that later. Angle, distance, distance, distance. So angle, distance, you can just select this edge and you can see how the angle is measured, 45 degrees. Distance is measured towards this edge. So if you want, you can flip the direction this way. So I will have say 15 millimeters this side, or else 15 millimeters this side. And angles also can be changed. So depending on the edge, you have to select the this whether you are measuring this way or this way. And tangent propagation is on full preview. You can see everywhere this fillet has been happened. So of this tangent propagation, this is the only edge I am getting the chamfer. So tangent on everywhere, I will get that chamfer. So you, I hope everyone can understand what is this distances. We can have two different distances, 15 or equal distances. Same result. And other options are like fillets. We have key features. We have discussed that one. And you have vertex option available as a new tool. So what do you mean by vertex? Vertex is I can select a common vertex connecting these three edges, and using that common vertex I can generate something like this kind of a chamfer. This is a special chamfer, so you cannot obtain it from normal tools. It's going to be difficult if you try to use normal cuts, because this cut happens to all these edges. So chamfer will help us to get that shape. So I will open the cube and show you how it works. So this is a special tool available in SolidWorks. Some softwares they don't have this, say vertex. So I will select this common vertex. That's all I should do. And we can adjust these distances separately and press OK. Now this is my chamfered output. So I am chamfer in this face as well as this top face. So otherwise, if you don't know this tool, you may have to draw planes and draw this shape and cut it. So I have to do a lot of work. So that's why they are giving this as a option under chamfers. So I hope you understood this concept also. Any questions, let me know. Just do it and see and check whether you are okay with the tool. So we have this wrapping feature only to be discussed. We will do it next day. So for the time being, you can start this tutorial. I will also help. We will start this tutorial and at home try to complete this tutorial. So uh, so when you get this kind of a shape, I said earlier, assume without the fillets, imagine without the fillet chamfers, imagine without the without the holes. So this is inside is hollow. That is, you have to apply shell. So to get the shell, we have to have a solid object. So to get the solid object, something like this, we have to get a without the fillets, we can get something like this shape. So to get this shape, we have to draw the necessary things. So we cannot draw everything available in the drawing. So when you get a drawing, we have to select whether I have to draw front view or the this is the plan view, this is the front view, this is the side view. So in this drawing, we don't draw the front view. Front view is necessary only to draw this bracket. I have to draw the plan view in this drawing. So plan view also, do I have to draw these holes? I don't need to draw the holes first. So we can extract the information and draw necessary things, only the necessary. So here also I don't need to draw the side view. Side view is helps me to get the heights and the thickness. So I don't need that even. So we have to minimize. We have to extract the necessary information and draw only this one. So I will place it here. So we need to draw only this. So when we get a drawing, it's up to you to decide where to start, where to draw, what to draw. So early days we drew the front view. Now we are going to draw the plan view in this example. I will draw. You can have a start and draw this shape. So after you draw this shape, you have to get these heights from this side and obtain a drawing like this. Just do it and see. I will give you time. I will also do it later. Just do it and see. Any questions, let me know. So if you do it perfectly, you will be able to have the full round fillets working here. So just try it and see. I will give you time. I will also start this and show you how it works. How you can approach to this question. So everyone will. I hope everyone can draw these kind of shapes at the moment now. So we will start this. So here origin is here in the bottom. So if you want, you can draw these slots. We have slot C. So we have discussed the slot 2. So we have these things available with us. So I can just try to draw the slot shapes. We will center point slots. So we will draw somewhere here. Uh, this is the origin. This point should coincide with the origin. So I can apply these coincident methods here, make it coincide, and slot size is given here 72. Then this is 10, that is 20. So this is 20. So this is 10, this is also 10. 20 given. So I drew this short shape. So if you try to get this readily available shape, you will save your time. So this can be also done from slot shape. So I will just use this one, center point slot. I am just drawing an arbitrary sketch, something like this. Then this value is 82 and this is 20 again. So this is 20. This is 82. Then the gap between the two slots are 60. So you can draw this rectangle, these rectangles, these rectangles. So all this you can use offset methods. So a lot of ways are available. So I will apply corner rectangle here. another rectangle here, another one here. So I don't know the values, we will just later we will adjust them. So this is symmetrical. So symmetrical. This is 28. Uh, 24. This is 20. This is 10. And from here to here it's 62. So these two lines are coincide with each other. So if you want, you can make this line coincide with this line. Collinear. From this one will be 62. So I drew this shape, this one, this one. So that's finished. My drawing is fully defined. Then I have to draw this shape. You can draw one half and get the mirror. So we have a line coming here and we can end up with here. So you can just draw a line somewhere here and do this way. Then later we will apply the fillets and the dimensions. So from here to here it's 30. So better we apply the fillet first. So this is 5. So here we have to apply a 2D fillet. The value is 5 dimension and click here. It's not enough. We will apply other values first. The fillet, specified radius is too much. 2 millimeters is going to work, not 5 millimeters. Later we will adjust it to 2 millimeters, 5 millimeters. So I think there's a problem with this line. Five millimeters. And from here to here it's 30. So this way we can obtain that. So if the 5 is not coming straight away, you apply a small value like 2 and 3 and did what I did and get the and do what I did and you can get something like this shape. Then we will mirror this. entities to mirror this one, and this one, mirror about this one. Okay. Now I almost got the correct shape. So I hope everyone is okay with this. And we have to trim the unnecessary things now. Trim this one. Now once I trim these things, you may see my sketch is no longer fully defined because I am removing the slot. So there will be problems. Almost okay, but it's not fully defined at the moment because I removed the slot, remove the slots. There's a small part here also, 60. So we can draw a rectangle there also, symmetrical. 60, height is 4. So when I change the height, something goes wrong. So these lines should be horizontal. So it's almost done. So I hope you are okay with this. Any questions? So I don't have a fully defined sketch, but I can make it fully defined by using these automatic tools. We have automatic tools. So we will try to make it fully defined. Sketch, most probably the problems are with these slots. So I asked software to do it for me. Still there are problems. Fully defined. It's getting problems. So I have issues with fully defining the sketch. We will leave as it is and move forward. Otherwise, it takes time to fully define. So I hope you understood the concept, how to draw the sketch here. Next is Next is we have to give the heights. So heights are available. So I have the sketch at the moment with me. So we will quickly add some heights. So heights can be taken from this side view. So we have also from here, say this is 5. Then if you look at the full model, it's 32 here in the middle. So this is 32. So we can select this inside and apply extrusion. So this is 32. 32. Then we have 4 here. Then we have 10 here, 10 here. Thirty-two given. Then 34 here. 32, 30, 34. So this is 34. This is 32. Sorry, 30. So we need to have this kind of a model. So I hope everyone can obtain that, this kind of a model. Then if you have done it correctly, these 2D sketches, you have to have 3D shape as this one. Then we need to apply full round fillets and get these round shapes. So I don't need to know the radiuses. We'll just apply last method on the manual full round fillets. So this face and this one and this. So once you do it and take the full fill, you should get it. Now here I have a problem. Fail to create Phillips. Please check the input geometry. So sometimes you may get these kind of issues. So if you are getting these kind of issues, don't get panic. We will try the other one. So all these are coming from the experience. So you need to don't give up your sketch. We have done it correctly. So we will try this side. So when you do this side, it's coming. So no problem with this side. So we will do the easy things first. So I did it this side. Then same thing we will apply for the middle. It's coming. No problems with the middle also. Now I had the problem here earlier. We'll try this now. Now it's coming. So that's the thing in SolidWorks. So earlier when I tried to start from this side, it didn't come. So I kept it aside and start from this side and came this side and finish it. So you can see how it works. Nicely I can obtain the full round flex. So you had at home try these things. Now after you obtain this shape, it's up to you to have design this bracket and these kind of two boxes. You can have one and get the 3D mirror and apply the shell feet. So shell is around 2 millimeters, I think. So when you get it, if you want, you can apply the fillets and do the shell, or just apply the shell for this model. Say I will get say 2 millimeters and select this entire face, preview and get it. So this is the output shell. So this is with the shell. So you can try that at home and try to complete this tutorial. Any questions, let me know next day. Uh, if you can manage this kind of a tutorial, it's you are somewhat okay with SolidWorks. You are good in. You can say you have done some work in SolidWorks. You know something about SolidWorks. So just try this at home and try to complete. Next day we will try. We will start pattern tools. So I have 2 more days to complete the design part. So maximum 2.5 days. So I will try to start chapter 8 next day. Under chapter 8 we are going to discuss modeling tools and the others. So this was got stuff. So we will meet next day and complete chapter 8. Yeah, we should with PowerPoint. So we will stop for the class. Stop the class for today. Next day we will meet. So you try to complete this tutorial. Any questions, let me know. Thank you for coming to the lecture. Bye.